Welcome to Math with Mrs. Bibb. Today I will be going over the review notes for the Algebra 2 Honors Summer Work Assignment number 3. First we'll review solving an equation, exponential equation. Remember, you want your bases to be the same. I can rewrite 36 with the base of 6 to the second power, and that will equal 6 to the third. Then what we will write below here is we'll write 2 times m minus 2, because power of a power we multiply, and that exponent has to equal 3. Then I will distribute 2m minus 4 equals 3. I will add 4. 2m will equal 7. I'll divide by 2, so m will equal 7 over 2. That's the answer to number 1. Number 2, I'm thinking about 81 and 27. 81 is 9 squared, but 27 cannot be rewritten as a base of 9. 81 is 3 to some power. 3 to 0 is 1. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27, so I'll rewrite that as 3 to the third raised to the 3v. And then 3 to the fourth, that is 81. So 1 over 81 would actually be 3 to the negative 4, because that base is in the denominator, and then the exponent is negative 2v plus 2. So now I have the bases the same. My exponents, of course, multiplied because of power of a power, are equal. Negative 2v plus 2 equals 3 times 3v. I'll go ahead and multiply. So positive 8v minus 8 equals 9v. Going to subtract 8v to the other side. Negative 8 will equal 1v, and v equals negative 8 is the answer. For number 3, I have graphed with Desmos the given inequalities, and I'm going to check to see if each of these listed order pairs are solutions, and I'll just write yes or no. So, and you do not have to draw the graph. You are welcome to just graph it in Desmos and then check to see. So I'm going to check negative 4, positive 3, negative 1, negative 2, negative 3, negative 4, positive 1, 2, 3. So that one is a no. Negative 4, negative 1. So negative 1, negative 2, negative 3, negative 1. That one is also a no. Oh, to be a solution to the red and the blue shading, it has to be in this purple region. So let me grab my pointer. It has to be in this purple region here. So both of the ones that I just plotted were not in that purple region. Negative 2, 0. Negative 1, negative 2, 0 is right there, and that one is a no. 3, negative 10. So positive 1, positive 2, positive 3. Negative 10, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10 is right here, so that's in the blue. So that one is also a no. 2, negative 8. So 1, 2, 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Are all of these no? And then 0, 5. 0, 1, 2, 3, 4, 5. Yep, those were all no. Interesting. Let's look at number 2. I covered up the inequalities with the graph. Hold on, let me move that down. There they are. I'll move this down. Okay, so to be a solution, it has to be, my original shading was purple and green, and so the solution is in this region, whatever color that would be called, where the purple and the green mix. So I'm looking for negative 4, positive 3. Negative 1, 2, 3, 4, 1, 2, 3. So that's a no. Negative 4, negative 1, negative 1, negative 2, negative 3, negative 4, negative 1. That's a yes, because it's here. That's -4, -1. -2, 0. -1, -2, 0. That's a yes. 3, -10. 1, 2, 3. -10 would be down here, so that's only in the purple, so that's no. 2, -8. 2, -8 would be here, so that's a no. And 0, 5 would be here, and that's a no. So that's all you have to do is write yes or no. Use your Desmos graph and decide if they are solutions. No work needed. Factor using the area model. Okay, so when I graded the assignment, a lot of students left off the work that I had expected to be shown. The first term goes in the top left box. The last term goes in the bottom left box. My choices of factors are 1 and 35 and 5 and 7. And I need to multiply. Oh, I can put my x and my x here. X times x is x squared. I need to multiply these two numbers and get positive 35, but add them and get negative 12. So that means I need -5 and -7. -5x plus -7x is -12x. Then that means my answers are x minus 5 times x minus 7. That is my answer to factoring using the area model. And next I'll make my box here. The first term goes in the top left box, second term goes in the bottom right box. My factors of 16 are 1 and 16, 2 and 8, 4 and 4. To get p squared, I multiply p times p. I want to add these and get -6p and multiply them and get -16. So it looks like it's going to be 2 and 8. And I need it to be negative, so I think it's -8 and +2. Let's try that. -8 times p is -8p. P times 2 is 2p. And -8 times +2 is -16. -8p plus 2p is -6p. So yes, that is correct. P minus 8 and p plus 2. So all of that work there should be shown on your paper for extra credit, and then it should also be shown on your paper in which I will be grading. Next, for the next problem. Factor using the method shown in Google Classroom. Okay, so that means we're going to factor by grouping. We need to check to see if we have a common factor, and I do believe we do. I think it's 5, but let me grab a calculator really quickly and you can do the same. Those are large numbers, and so you definitely will want to use a calculator. I know I can divide 45 by 5. So 9n, I'm just going to go ahead and write that. 5 times 9n squared minus 55n plus 6. And that is the biggest common factor. So A is 9, B is -55, C is 6. Factors of A times C. 9 times 6 is A times C, so positive 54. Sum of B, which is -55. So I want to multiply and get a positive and add and get a negative. That means that both of them will be negative. And since the first one's the one that works, that's the only one I'm going to put. I'm going to bring this down. And that's where my answer is going to go. I'm going to rewrite 9n squared minus 55n plus 6 is 9n squared minus 1n minus 54n plus 6. I'm going to group the first two together, put a plus sign, group the last two together. The first group has n in common. Divide both of those by n. Please show this work. So 9n minus 1 plus the second group has 6 in common. Oh, and I want to undo that. And the first term is negative, so I'm going to take out a negative greatest common factor. So negative 6, divide them both by negative 6. That will be 9n minus 1. And then that did work because these two are the same. That's what I'll put in the first group, 9n minus 1. And then n minus 6 goes in the second group. So that is 45n squared minus 275n plus 30 factored. Now looking at number 8, I don't think there's a common factor. 3 goes into 9 into 60, but it doesn't go into 64. 9 only goes into itself. 1 and 9, 3 and 3. So no, there's not a common factor. So I can name A, B, and C. A is 9, B is 64, C is 60. I want factors of A times C. 9 times 60 is 540. That will give me a sum of B, which is 64. So 1 times 540, of course, does not work. 2 times 270, is that right? That's probably right, but I'm going to check. 540 divided by 2. Yes, 2 times 270, which does not work. 3 does go into 540 because when you add the digits, you get a sum that is divisible by 3. So 3 times 180, which is not 64. 40, the last two digits are divisible by 4, so 540 is divisible by 4. And 4 times 135 is not it. Of course, 5 goes into 540. Is that 108? Yes, 5 times 108. 6 does because 2 and 3 does. That's 6 times 90. We're getting closer because 90 plus 6 is 96, but that's not it. I do not believe 540 is divisible by 7. 540 divided by 8. Nope. Divided by 9. 9 times 60. We're getting closer. And then 10 times 54. 10 times 54. I should have seen that one to start with. That's the one that works. Okay, because 10 plus 54 is 64. I'm going to rewrite that as 9x squared plus 10x plus 54x plus 60. I'm going to group the first two together. Group the last two together. Put a plus sign in the middle. The first group has x in common. 9x, divide both of those by x, that'd be 9x plus 10. The second group has 6 in common. And 54 divided by 6 is 9x plus 10. Yes, it did work because those two parentheses are the same. So my answer is 9x plus 10 times x plus 6. That's the answer to number 8. Number 9, do I have a common factor? No. So then I know A is 9, B is 21, C is negative 8. I want factors of A times C. So factors of negative 72. That will give me a sum of B, which is positive 21. I'm going to multiply a positive and a negative, and the smaller one has to be negative because the sum has to be positive. So negative 2 times 36, neither one of these work. Negative 3 times 24, that's what works. So I'm going to rewrite 9b squared plus 21b minus 8 as 9b squared minus 3b plus 24b minus 8. Group the first two together, put a plus sign, group the last two together. The first group has 3b in common. That would be 3b minus 1. The second group has positive 8 in common. That would be 3b minus 1. It worked because what's in parentheses is the same. So the quantity 3b minus 1 times the quantity 3b plus 8 is the product of those two. And next, I know all of those are divisible by 2. I wonder if they're all, I know 60 and 60 is divisible by 6. I don't know about 174. Yes. So I wonder if 174 is divisible by 12. No. So I think 6 is the greatest common factor. So 10x squared minus 29x plus 10. And 29 is prime, so that is the greatest common factor. So A is 10, B is negative 29, C is 10. I want factors. So the things that you multiply of A times C, which would be positive 100, to give me a sum of B, which is negative 29. So it's going to be a negative times a negative. So negative 1 times negative 100, no. Negative 2 times negative 50, no. Negative 4 times negative 25, yes. So I found what works. I'm going to bring this down here. 6 times both of those pairs of parentheses. 10x squared minus 4x minus 25x plus 10. Group the first two. Put a plus sign. Group the last two. The first two have 2x in common. And that leaves me 5x minus 2. The next group I have to take out a negative because the first term is negative, and negative 5. So negative 25 divided by negative 5 is positive 5x. 10 divided by negative 5 is negative 2, and it did work. So it's 6 times the quantity 5x minus 2 times the quantity 2x minus 5. And that's the answer to number 10. Moving right along. Simplify. Okay, so the first two, it's just telling me to add. I think I'm going to make this one subtract. So please make sure you write that down on your paper because we need to also know how to subtract them. So the first two, I'm just going to add like terms. So just going to do like terms here for the first two so you know that. I'm going to start with the largest exponent because that's what we should start with. So x to the fourths are my largest exponent. I'm going to add those, so that's 10x to the fourth. So these are gone. I'd write down the original problem and then mark them out as we go through them. X to the third would be next. So I've got negative 6x to the third and positive 5x to the third. So that'd be negative 1x to the third. And then x to the second would be last. So 2x to the second minus 7x to the second is minus 5x to the second. And this is my answer. Okay. The next one I'm going to subtract, and my best advice for you is to rewrite this as addition and then change every sign. Distribute your negative one. So that'd be negative 3n to the fourth plus 8n to the third minus 8n. Now, if your assignment has two addition problems, don't change it because I'll forget. But on this particular set of extra credit notes, please do change that. And remember that this is how you would do a subtraction problem. So I'll start with my largest exponent, which looks like it's n to the fourth power. There's only one of them. Whoops, it's this one. Negative 3n to the fourth. Next would be third. Whoops, and I can see I messed that up. So that's positive 8n to the third. And negative 5n to the third, so that'd be plus 3n to the third. Okay, so those are gone. N to the second is next. And there's only one, so negative 6 n to the second. And then n to the first. So 4n minus 8n is negative 4n. And that's my answer. Now for 13 and 14, and also 15, 16, 17, and 18, but 17 and 18 are just written a little bit differently. We're going to distribute, and this is how we're going to write our work. We're going to write 7m times 2m minus 3, and then 1 times 2m minus 3. So 7m times the quantity 2m minus 3 plus 1 times 2m minus 3. Then we're going to distribute. 7m times 2m is 14m squared. 7m times negative 3 is negative 21m. 1 times anything is itself. And then the middle terms are my like terms, so my answer is 14m squared minus 19m minus 3. That's the answer to number 13. Number 14, again, we're going to multiply 4m times 2m minus 5. Then we're going to multiply negative 3 times 2m minus 5. So 4m times the quantity 2m minus 5 minus 3 times the quantity 2m minus 5. Distribute. 4m times 2m is 8m squared. 4m times negative 5 is negative 20m. Negative 3 times 2m is negative 6m. Negative 3 times negative 5 is positive 15. Then we're going to add the two middle terms. Those are my like terms. 8m squared minus 26m plus 15 is my answer. So you can tell we're going from factored form, number 14 is in factored form, to distributed form. So remember, when we're factoring, we're going from what's in this box here back to the original. So we're undoing the distributive property. What we're doing is we're doing the distributive property, and that is my answer, doing the distributive property. Now, when you have a binomial or trinomial, it really doesn't change the process. You're going to multiply 2r times this trinomial, and then 1 times this trinomial. So that's what we're going to do now. 2r times 6r squared plus r plus 4 plus 1 times 6r squared plus r plus 4. Multiply, distribute your 2r, that'd be 12r cubed plus 2r squared plus 8r plus 6r squared plus r plus 4. Combine like terms. 12r cubed does not have a like term. 2r squared and 6r squared is 8r squared. 8r plus 1r is 9r plus 4. That's my answer to number 15. Number 16, I'm going to multiply 5r times 4r squared plus 3r plus 8. Then I'm going to multiply minus 2 times 4r squared plus 3r plus 8. So 5r times 4r squared plus 3r plus 8, and then negative 2 times 4r squared plus 3r plus 8. And hopefully you remember learning this in Algebra 1, because all of this does come from Algebra 1 content. 5r times 4r squared is 20r cubed. 5r times 3r is 15r squared. 5r times 8 is 40r. Negative 2 times 4r squared is negative 8r squared. Negative 2 times 3r is negative 6r. Negative 2 times 8 is negative 16. Combine like terms. 20r cubed does not have a like term. 15r squared minus 8r squared is plus 7r squared. 40r minus 6r is plus 34r, and then minus 16. That's the answer to number 16. Now, number 17, be very careful. This one is missed really often by a lot of people. You have to remember that you are multiplying 6n plus 5 by itself, and then you are multiplying 6n times 6n plus 5 and positive 5 times 6n plus 5. So when you have that quantity squared, you are still distributing just like those other problems, plus 5 times 6n plus 5. I'm going to distribute and get 36n squared plus 30n plus 30n plus 25. These two are my like terms. So my answer is 36n squared plus 60n plus 25. That's the answer to number 17. Number 18, I'm going to write that twice, just like it says, multiply that quantity by itself. I'm going to multiply 1 times 1 minus 7n and negative 7n times 1 minus 7n. 1 times 1 minus 7n, negative 7n times 1 minus 7n. Distribute. When you multiply 1 by anything, you get itself. Negative 7n times 1 is negative 7n. Negative 7n times negative 7n is positive 49n squared. I'm going to put this in descending order, so 49n squared will go first. Negative 7n is negative 14n, then plus 1. That's my answer to number 18. Moving right along to the next one. Now, to factor completely is very similar to what we had before, except it's possible that we could have a difference of squares. So I want you to remember that a difference of squares from Algebra 1 is when you have two perfect squares that are multiplied, and it factors into two binomials, one with a plus, one with a minus, and you take the square root to get each term of the binomial. Square root of b squared is b. And perfect squares, you'll see, if you want to pause the video and fast forward, I have a whole list of perfect squares on one of these slides. I think it might be on the next one. But if you want to see that, I'm pretty sure that we're going to encounter a difference of squares soon. All right, so we also want to look for a greatest common factor, and I'm going to say 6 is probably the greatest common factor, but I'm not for certain. Yes. Well, maybe. Yes, 6 is. So I'm going to take out 6, so that'd be 6r squared minus 23r plus 10. So A is 6, B is negative 23, C is 10. Bring down this 6. That might be my final answer. I'm gotta watch out for, oh, I won't have difference of squares here because of that r squared. So I'm gonna just go ahead and say that's my answer. Okay, factors of A times C. So factors of 60. Sum of negative 23. They're both going to be negative, both factors, and that's not it. Negative 2 times negative 30, that's not it. Negative 3 times negative 20, that is it. So I'm going to go ahead and group, and you're welcome to do that too. So 6r squared minus 3r plus negative 20r plus 10. The first group has 3r in common. Divide by 3r, so that would be 2r minus 1. The second group has a negative greatest common factor, negative 10. Divide both of these by negative 10, so it'd be 2r minus 1, and it worked. So 6 times the quantity 2r minus 1 times the quantity 3r minus 10. That is number 19 factored completely. For number 20, I know a squared is a common factor. They all have a, and this is the least a's that they have, and I think that's it. So a squared times 9a squared minus 74a plus 16. So I want factors of a times c. Factors of 144. That'll give me a sum of negative 74. So positive product, negative sum. So a negative 1 times a negative 144 is a no. A negative 2 times a negative 72 is a yes. Negative 2 plus negative 72 is negative 74. Okay, I'm going to bring this down. I'm going to put a squared. I know I'm not going to have a difference of squares, and I'll tell you why I know. Because this here, that is the largest exponent of 2, and so it factors into, it's a trinomial that factors, so you can't have a difference of squares there. The only way I could is if I had to the 4th power there in that place. Okay, so I'm going to go ahead and group 9a squared minus 2a, put a plus sign, negative 72a plus 16. A is the greatest common factor in the first group, so that would be 9a minus 2. Negative 8 is going to be my greatest common factor in the next group. Divide by negative 8, so that would be positive 9a minus 2. It did work. 9a minus 2. So what they have in common, a minus 8, is what's left when you take away 9a minus 2. All right, let's look at the next group. Greatest common factor. 2 for sure. 4 for sure. Wonder if 8. No. But 116 is divisible by 4. So 4n squared minus 29n plus 30. Okay, so 4 is going to go down here. Factors of a times c, so factors of 120. That will give me a sum of negative 29. So both factors are negative because I want to multiply and get a positive and add and get a negative. So negative 1 times negative 120 is a no. Negative 2 times negative 60 is a no. Negative 3 times negative 40 is a no. Negative 4 times negative 30 is a no, but I'm getting closer. Negative 5 times negative 2, is that 24? Yes, and that's a yes. So negative 5 times negative 24. When you add them together, you get negative 29. So I'm going to go ahead and group 4n squared minus 5n, put a plus sign, minus 24n plus 30. The first group has n in common, and that would leave me 4n minus 5. The second group has negative 6 in common, and that would leave me positive 4n minus 5, and it worked. They have 4n minus 5 in common, and when you take 4n minus 5 away, you have n minus 6. So that is the factored form of 16n squared minus 116n plus 120. Now the next one, I have a common factor. I know 5 goes into both of those. Wonder if 9 goes into 360. I think so. 40 times? I think 9. I don't think 360 is divisible by 45, but I could be wrong. Yes, it is. Okay, so 45K is the greatest common factor. And 45K squared divided by 45K is just K. Minus 360 divided by 45 is 8, and K divided by K goes away. And this will not factor anymore because it's a binomial and it's not a difference of squares. So this is the answer to number 22. Moving on to 23. Okay, I'm going to factor that completely. We'll change these two. We'll change this to 4x squared minus 64. And I'm going to change that to, give me a second to think. $50x squared minus 8. 50x squared minus 8. So I'm changing both of those to those two problems. And notice it had raised to the second power, just means x squared. Okay, for the next one, there's not a greatest common factor. A is equals 6, B equals 5, C equals negative 6. Factors of negative 36, that'll give me a sum of 5. Okay, so I want a negative product. One's positive, one's negative. Positive sum, so the smaller one is negative. That's not it. Negative 2 times 18, that's not it. Negative 3 times 12, that's positive 9, I'm getting closer. Negative 4 times 9, that's it. That's what works. So 6x squared minus 4x plus 9x minus 6. I could have go ahead and group those. You're welcome to do that if you want. Just put a plus sign in the middle. The first group has 2x in common. That'd be 3x minus 2. The next group has positive 3 in common. That'd be 3x minus 2. And it worked, so it's 3x minus 2 times 2x plus 3. That's the answer to number 23. Number 24. 36 goes into 72. Does 36 go into 332? No. So 6 goes into all those. So 6 is my greatest common factor, I bet. So this would be 6x squared. Nope, 6 does not go into 332. 2 does, so let me just undo all that. So 2, this would be 18x squared minus 166x plus 36. Those are all still even, so 4 must go into all of them. Okay, let's get rid of that. So 9x squared, no, 332 divided by 2. Oh, it's 166, but 2 will still go into it, so 4, I'm so sorry, 9x squared, 332 divided by 4. 83. I don't think I got that a second ago. Minus 83x. And then is that 24? 72 divided by 4. 18. See? 18. And those do not have a common factor. So 9 times 18, 72, 162, I don't know. Times 18. Yeah, 162. So I want factors of 162, sum of negative 83. So 2 negatives, and that's not it. Excuse me. Negative 2 times negative 81. That is it. 81 plus 2 is 83. So these two are what works. I'm going to bring this down. I am going to go ahead and group. So 9x squared minus 2x plus negative 81x plus 18. The first group has x in common. That would be 9x minus 2. The second group has 9 in common, negative 9. Negative 9 divided by negative 9. And that would be 9x minus 2. And so it factors into 4 times 9x minus 2 times the quantity x minus 9. That's the answer to 24. Now for 25, these are not trinomials. So I'm going to factor out a greatest common factor. 4 times x squared minus 16. And for this one, the greatest common factor, 2. 25x squared minus 4. And then I'm going to look for a difference of squares. Well, both of these are a difference. I have subtraction. And x squared, 16, 25, and 4 are all perfect squares. So I'm going to rewrite that as two binomials, one with a plus, one with a minus. You take the square root of the first term to get the first term of each binomial, and the square root of the second term to get the second term of each binomial. So this is your formula. Bring down your greatest common factor, two empty binomials, one with a plus, one with a minus. I do expect to see you taking the square root of x squared. That's x. And the square root of 16, that's 4. I know 4 is a perfect square, but x is not a perfect square, so that means this is my answer. Same thing for the next one. I'm going to bring down my 2, put two empty binomials, one with a plus, one with a minus. I'm going to take the square root of 25x squared, which is 5x. I'm going to take the square root of 4, which is 2. And that is my answer. So that's how you factor a difference of squares. And now here's that list of perfect squares. Here we're simplifying radicals. Hopefully you learned this in Algebra 1. Should have been one of the last things that you did in Algebra 1. For 27 and 28, I'm adding like terms. So when I look at this, for 27, these two are like terms. I have negative 3 square roots of 5 minus 2 square roots of 5. That's negative 5 square roots of 5. Then I don't have anything to go with that, so it's plus 3 square root of 2. That's the answer to number 27. Number 28, I have negative 3 square root of 2 plus 3 square root of 2. Those go away. They make 0. So my answer is 2 times the square root of 3. I'm going to hop down to number 34 and do that one. If you want to do it out of order, fine. If you want to just rewind and then watch 29, 30, 31, 32, and 33, you're welcome to do that. But 34 is related to 27 and 28. Now, I can't do anything with these. I could combine these because they're like terms. I'm not going to. I'm just going to simplify each radical. So 8. 8 has factors 1 times 8, 2 times 4. And 4 is in this list. 4 is a perfect square. So I'm going to rewrite that as negative 3 times the square root of 2 times the square root of 4. Maybe I will go ahead and combine these. That would be minus 4 times the square root of 54. I'll do this one first. I'm just going to bring this down. Negative 3 times the square root of 2 times the square root of 4. Then I'm going to work on this one. Minus 4 times, and then I'm going to work on 54. 1 times 54. 2 times 27. 3 times 18. 6 times 9. And the perfect squares are just 1 and 9, and 9's the biggest one. So I'm going to rewrite that as the square root of 9 times the square root of 6. Now, I have perfect squares. This is a perfect square. This is a perfect square. So I'm going to rewrite that as negative 3 times the square root of 2 times 2 minus 4 times 3 times the square root of 6. Let me highlight something to show you. So all I just did was I rewrote this and I rewrote this. Everything else stayed the same. Now I'm going to multiply my like terms. I'm going to multiply this and this and this and this. So I have negative 6 times the square root of 2 minus 12 times the square root of 6. I would check to see if I have like radicands. I do not. So this is my final answer. It's because I combined my like radicals at the beginning. So that's how you do number 34. Now, number 29, I just need to come up with the factors of 294. 1 times 294, I do not know what that is, divided by 2. 1, 4, just 8. I gotta go look. 294 divided by 2. 147. 9 to 11, I think 3 goes into it. 3 times 98. 4 does go into it, I believe. No, it does not. Thought it would, but I guess 94 is not divisible by 4. 6 does go into it, because 2 and 3 do. 6 times 49. And there's my biggest perfect square. 1 and 49. So you're going to use your biggest perfect square. You're going to rewrite 294 as the square root of 6 times the square root of 49. The square root of 6 is not a perfect square. The square root of 49 is 7 because 7 squared is 49. So my final answer is 7 times the square root of 6. Number 30 for 63, 1 times 63. 3 times 21, 7 times 9. Perfect squares are 1 and 9, and this one's the biggest one. So the square root of 7 times the square root of 9, square root of 7 times 3, so 3 times the square root of 7 is my answer. The next one, 1 times 96, 2 times 48, 3 times 32, 4 times 20, 24? Yep. 6 times 1, 16. So 1 and 16, with 16 being the biggest, so I have negative 8 times 6, oh no, sorry, the square root of 6 times the square root of 16. So negative 8 times the square root of 6 times 4, not the square root of 4, 4. Multiply these two things. So negative 32 times the square root of 6 is the answer. For the next one, I'm going to have 4 times 2 radicals. Don't know what they are yet. I'm going to do that over here. 384 is 1 times 384. 2 times 192. Always have to check myself because I make 199. See, told you. 199. 12. I think it is divisible by 3. 3 times 128. 4 times 96. 6 will go into it. 6 times 64. And that's it. That's the biggest perfect square. So I had 1 and I had 64, and 64 is the biggest. So this would be the square root of 6 times the square root of 64. Bring down your 4, bring down your square root of 6. The square root of 64 is 8. And then multiply these two. 8 times 4 is 32 times the square root of 6. And then the last one, I'm going to distribute the square root of 2. I'm going to write that out so you can see what that looks like. Okay, 5 is on the outside. Square root of 2 times the square root of 2 is the square root of 4. Plus the square root of 2 times the square root of 3 is the square root of 6. The square root of 4 simplifies to 2, so 5 times 2 plus the square root of 6, and then that's 10 plus the square root of 6. Those are not like terms, you can't add them together. That's the answer to number 33. Please reach out if you need help. Some of that you may never have seen, you may not have gotten to that in Algebra 1, but if you were in Algebra 1 Honors, we did go over this. So hope you have a wonderful day and enjoy what's left of summertime. It won't be long. We'll be together learning, and that's it. Have a great day.